Openstax Calculus Volume 1. We're going to use the squeeze theorem to evaluate this limit. And what we do is that when using the squeeze theorem, we need to construct, put together an inequality. And really often, when we either see sine or cosine, and we're looking for an inequality, when I see a cosine or sine, I begin with this part here where I remember I use the fact that cosine has a maximum value of 1 and a minimum value of -1, and that's regardless of what the input is. So if you add anything else here, alpha or something, anything else in there, it doesn't matter what that is, we have that bound. All right, and then what I do is I multiply everything by theta squared, which is never negative. And because it's never negative, I do not have to think about whether I should change the direction of the inequality. Remember, when you multiply by a negative number or a variable that's negative, then it'll change the direction of the inequality. But that's not what's happening here, because theta squared is never negative. And because theta is approaching 0, theta should not equal 0 either. So we multiply by theta squared. And the reason I'm doing that is because I want a inequality that has 3 components. And I'm hoping, and which I did do, that I have our difficult looking or function I don't know what to do with in the middle. So that's in the middle. And then on the outsides, I have a function that I think I can get a handle on, these 2 functions, and I can easily find the limits. So I get the inequality, and the next thing is I find the limits of those outside functions, what I'm calling outside functions, and those are just polynomials. Limit of negative theta squared will be 0 squared, which is 0. Well, you can put the negative, but it looks funny to put negative in front of 0, but theta approaches 0 of theta squared, and that's 0 squared, which is 0. So what we see is that those 2 outside functions have the same limit. And therefore, that fact, along with the inequality, allows me to conclude that the inside function has that limit of 0. So therefore, limit theta squared cosine 1 over theta equals 0 as theta approaches 0 by the squeeze theorem. And we need to show all those steps. It is essentially it's a proof. It is not what's the limit and whatever plotting points or whatever at 0. We need to show all the steps, and we need to use the squeeze theorem. Not what is not allowed. This is a big no. I'm going to erase it. No, we are not allowed to just put limit in front of everything. Why aren't we allowed to do that? Because when we begin the problem, we do not know that the limit of that inside function exists. We don't know that exists. So saying that we have that inequality limits is simply not correct, and it's not the squeeze theorem. That's using a theorem that says if I know the limit of those functions exist and I have an inequality, then if I have an inequality, then the limit applies to the inequality. So this is just incorrect, not good, bad stuff. I mean, whatever.
How did you know that to do 0 squared? Was it because of the direct substitution?
No, it's simply because this is a famous problem in calculus 1 books. If you look at any beginning calculus book, they have this problem or something similar. What we did in class, because it's out of the book, is they had x squared sine 1 over x. So I've just done this problem a bunch of times. I mean that's a lot of math and learning and so forth, is you have a database of problems you've done before, and then they might change it a little bit, and you're like, oh, okay, well, I did the one that's basically the same, except instead of theta, they have x, and instead of cosine, they have sine.